好，那大家好，看大家都已经入座，那我们就稍微先介绍一下，等下就可以准时开始。这场的议程是 R1 的下午的议程，这个标题是 A phish and detection engineer walk into a bar， 那是由这个 Manabu Niseki 上还有这个 Dekai 上。OK，so 他们是Are you using your company name or not? No.
I don't care.
Okay. Yeah, they work for a famous line security team in Tokyo, and my girlfriend. So they are specialized in a lot of security related work. Especially I know they are doing on like a fraud detection and improving a lot of how to prevent the abuse of line messenger. 然后我们就是这次非常荣幸邀请他们为我们介绍这个 detection engineering。detection engineering 是一个台湾比较少见的一个这个制度，但是在国外非常的成熟，就是如何把侦测这些规则，像是防火墙入侵规则或者是诈骗盗刷的入侵规则，变成一个制度化、系统化的程式码，叫 detection as a code。那因为我们常常写一大堆的规则，可是这些规则commit到防火墙之后，下一个人来的时候，没有交接，不知道怎么改。但如果我们把这些 code 放到像 GitHub， 要用 Git 来管理这些 code， 每一条规则都是清清楚楚在 Git 上面。有人要改的时候，就先去 Git 去改它，然后再 commit 到防火墙设备。这样子 detection as code 的流程就可以让这个稳定性增加，然后也不容易交接失误。所以这个概念是我在美国常看到，但在台湾觉得比较缺的。那非常谢谢他们愿意投稿这个。让我们热烈掌声欢迎 Niseki 上还有这个 Dekai 上来为我们演讲，谢谢。
Or you can use this.
Oh,
Both of
okay. Let me start this presentation. And first, I'd like to say sorry for interpreters because I created a too long presentation note, so we may speak very fastly. So sorry for inconvenience, but please be patient with us. And let me start the presentation. And we are going to talk about how we use detection as code idea in phishing website detection, and we will explain what detection as code is and practical tips. And this talk doesn't focus on the phishing, but focus on the detection as code. So we wish you can have some takeaways. And the introduction part is already over. I'm Manabu Niseki, and he's Wally, also known as Dekai. Dekai also known as Wally. So yeah, we are working as a trust and safety team in the LY Corp, which stands for Line Yahoo Corporation, which is a very strange company name. But yeah, we are working as a trust and safety team in the company and tackling with anti-phishing. So
yeah, so for today, let me start talking about the background of our research here today. So for us, well, a lot of people use Line, right? We can actually see that there is a lot of, line themed phishing websites, especially in Taiwan as well. So the phishing actors try to steal passwords, they try to steal usernames and try to do an account takeover. Just as a summary, we've detected quite a lot, about 400 cases in just 7 months. And we tend to see quite a bit of patterns in terms of via like IPv4 cases and also what domains they use. However, these form generally a type of patterns that we can use to make rules to see, okay, whether a website or a URL is actually a suspicious website or not. So this way, if there are rules that we can use, we can obviously use what we call detection as code concepts, and I'll be explaining how we use it in our company. So I think in terms of detection as code, probably some of us here are engineers, and we probably use things like Terraform. We use things like AWS CDK. Basically, it means infrastructure as code. We basically see what infrastructure we can provision using what code we write. And in the same case, the power of IAC is that you can put things onto GitHub, you can do version control. Now, same as detection as code, we can put rules, we can put response rules onto GitHub, and we can see what works, what doesn't, and if it doesn't work, roll it back. If we need new features, do a pull request into your code base. So the idea is that, okay, why is this better than manual deployment or manual rule management? It's because, well, you have GitHub, right? And For example, if a rule doesn't really work out, there's a lot of false positives, it's very easy for you to roll it back. Just do a PR, say, I want to revert this. You're done, right? And with a PR, it means that if you do a PR, people can obviously review your code. So people, before they approve that PR, they have to understand what you're writing. This helps to share knowledge throughout the team, so we know that, okay, this rule or this thing works, and potentially I want to understand why this was made, and people can agree on something, and we publish this as a rule to detect websites, for example. And as engineers, right, I'm assuming all of us are engineers today, and good engineers write unit tests, right? Okay, so for us engineers, I think that there's a lot of small errors that we want to try and avoid, right? Like formatting errors. So CI/CD such as Circle CI, GitHub Actions, all of these can automate your tests and help you even deploy this code into your live application very, very easily. So you don't have to manually do it yourself. Saves a lot of time. So in terms of our pipeline, right, we split it up into a couple of sections. So as in the generic detection as code pipeline, we have always to start with the modeling phase, i.e. what are we trying to detect? What does the event actually look like? Then the development. Based on that event, what can we do to detect that event as whatever you want, for example? And then we also run tests on it, right? So once you've made a rule, you want to see whether, okay, is this really working correctly or not? And if you're writing code, sometimes, you have too much tabs or your type errors are there. This linting will help you very, very quickly check whatever coding errors that you have and help clear it very, very fast. And then the last two steps rather, is the review, just to see whether everyone is on the same page. And then the deployment. Once the PR is accepted, pushed into the main branch, and automatically it gets deployed onto the live site. So now we know the general outlines of detection as code. We would want to go into what use cases that we have, right? So generally under collection, for example, you need to get data from somewhere, right? So you have to first see, okay, where are the points can I get the data that I want? And how can I extract the data that I want? And then with this data, how do you then assess whether, okay, this is the correct data, this is the one that I want to detect. And then if, let's say, you detected something based on your rules, how do you respond to this? Is there anything that you can do? And now, in the case of phishing in our company, we have a couple of sensors, i.e. the data points that we take from. So, for example, virus total and URL scan, they can automatically report sites that are they're suspicious and could potentially be phishing. But as a very, very big messenger platform, we also get a lot of reports from real users that, hey, someone sent this very suspicious site to me. So this means that actually, if we want websites to assess, like, okay, these might be phishing websites, we can actually get it from these three very, very big sources, rather than going through every available URL on the internet. We know that's not possible. So right now, we are using these three sources as URL or website sources to check whether it could be suspicious or not. And for the detection, I'm going to go a little bit generic here because the specifics will be talked about a little bit later. But once we get a URL, we extract data from it, and this concept called HAR, which is the HTTP archive file, is going to be very important. It will be talked about a little later. And once we get the website data via this HTTP archive file, we then run it through a set of Rego rules. Remember, I talked about modeling, right? You have an idea of, okay, a phishing site should have so and so. We run it through a set of Rego rules, and it will then tell us whether this site is, okay, this site seems to be a phishing website, or this site seems to be a normal website. And then, if we realize that a website is suspicious, then we proceed into the response phase. Now, no one likes doing manual work. Nobody, right? So what we can do is we can see, let's say, okay, this website sounds like, all right, it doesn't look like, it looks suspicious. What we can do is that we can automate, or we can see what we need to do, and then we can automate it based on what is feasible or not. So for example, things like registering the website onto Google Safe Browsing as a block list, right? There's an API for that. You can immediately get the URL or the domain, and then you can send it over to Google Safe Browsing just by an API call. Very simple, you can automate that. However, the next step is to take down that website. You want the website to actually not be accessible anymore, right? The problem with that is that you will need to see, okay, where is this domain registered? And then you need to see where is this suspicious website hosted. The problem with this is that there's two problems, right? Number one, each hosting provider and registrar has different forms. So if they have different forms, how are we going to automatically submit a takedown request to these websites? And the second question is that, okay, let's say even if we do manage to automate these form submissions, most of these forms are protected by CAPTCHA. So this is the last problem, to be honest, that we cannot automate. So essentially the detection, the rules, how to ingest everything, it's all automated, but the registration itself is a little difficult. So right now, it's still the last manual thing that we have on the plate.
Okay, next, let me share chips lesson we've run through adapting detection as code into our work, phishing website detection. First chips are about data modeling. I think data modeling is the most important thing in detection engineering because you cannot create a good detection rule if there is no good feature, good field in the data model. For example, it's common to say something like, I cannot create a detection rule for that because there is no field. For example, command line is missing in the log or event, so I cannot create a detection rule. So it can be happen very easily. So you have to create a good data model for do good detection engineering. And there are some tips for good data modeling. First one is don't reinvent the wheel. If you have a chance to define a data model as you want, it's good to stand on the shoulders of giant. I mean, it's good to use a standard because a standard is already battle tested and it has a higher coverage than your own invented data model in most cases. For example, we use HTTP archive format, which is standard to express what will happen when we accessing a URL, and it has a good coverage in terms of data modeling, and also some tools, for example, Google Chrome, Playwright, blah, 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 supports her export and also her ingestion. So it's very easy to use it. And it also does it work? Oh.
Yes.
Oh, sorry. Oh.
LED screen doesn't reflect. So
Okay. Sorry, please forget it. And I also recommend to define features that the threat actor cannot change with ease. For example, whether it has logo or whether it has password input form, blah, 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 because, threat actor cannot create a line payment phishing website without having line's logo, right? So it's good to define a feature like that in the data model. The next chips are about development. I mean, how to write a detection rule. And I'd like to emphasize that don't write on indicators. Indicators means hashes, URLs, IP addresses, domains, blah, 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 as much as possible. Because it's very easy to change them. In other words, don't write rule like this. It's wrong. Yeah. Please don't write a rule like this because, it's easy to evade this detection rule because, inputting one character, changing one character, inserting one space, change the hash. So this detection rule is very fragile. Instead of that, it's better to focus on TTP. TTP stands for tactics, techniques, and procedures, and also, they are also subject to change, but they are more durable. For example, in terms of phishing website detection, it's good to check which framework, for example, Vue, React, jQuery, blah, 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 is used, and also check what kind of data schema, data format is used for the communication. Also, it's very important to select a right detection engine based on the data model. So let me explain it more deeply. I selected Lego because of the based data model. Let me explain why I selected Lego over more commonly known detection engine, Yara and Sigma. And Yara is good, but Yara is like a flat earther. It's good to deal with binary data, but it's difficult or impossible to do a field-based selection or comparison. In other words, how do you select who in this following JSON data by Yara? Maybe some of you say, I can do that, but I think it's because you have a black magic Yara power. It's very difficult. So this is a reason why there are Yara JSON, which is a Yara C module for finding key and values in JSON file, and also Yara L, which is a Yara variant can select a field like this, metadata event type, principal process command line. But Yara L can do that, but it's not open source. It's only available on Google Chronicle as far as I know, so it cannot be our choice. Sigma is also a very good detection tool, but Sigma is kind of, let's say, it's a one-dimensional thinker. I mean, Sigma is bad at dealing with, for example, a list of object like this. It's a list of user object which has name who bar, and I'm not absolutely sure about it. May depend on backend, but in general, Sigma is not possible to select something like users.name. So there is a Sigma-based phishing detection tool known as IOK. It stands for Indicator of Kit, but this tool has the problem I explained. For example, this is a data model IOK uses, and you can see there is no list of objects, but it has a list of strings, something like that. So it abstracts JavaScript as a list of strings. So you cannot compare something like a file name should be blah, 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 and its content should be blah, blah, blah. You cannot create such condition because of the limitation of Sigma. And I selected Lego, and I think most of you guys already know about Yara and Sigma, but only a few people knows only a few people know about Lego. So let me explain it briefly. The Lego was inspired by Datalog, which is decades-old query language, and Lego extends Datalog to support structured document models such as JSON. So in general, Lego is used for authorization and authentication, but it can be used as a general purpose classifier, and Lego doesn't have a problem I explained. Because of the time limitation, I don't have a time to explain the details of Lego, but you can create a Lego rule, which is also known as policy. You can write a rule like this. This is a Lego rule to, check how data come from the example.com or not, and let me demonstrate it. Input, excuse me. This input is hard data, and it has a list of entries, which is the HTTP list of HTTP requests and response, and it comes from example.com, and it checks whether the data comes from example.com or not by these comparisons, and let's evaluate it. It returns. I don't like online demonstration, real demonstration, because I tend to have errors. Let's do it again. Yep. It outputs true, but we can, if you change the request URL as example.net, it should be return false. So you can write a detection rule like this by using OPA Lego. And sorry. So I said that IOK cannot have a condition like the file name should be blah 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 and its content should be blah blah blah. But with OPA Lego, you can do that. like those, like this. And I said OPA Lego is used mainly for authentication and authorization, but it is also used in the detection engineering. For example, Tafel Security's Log Warden, which is a Lego-based GCP. Excuse me, it's a tool to process all of your GCP audit logs against OPA Lego, and it makes an alert if there is a violation. For example, this is an alert which detects the possible data exfiltration attempt by using Lego, and let me show corresponding Lego rule for that. There is not much time to explain what is it. To be honest, I'm not sure about I'm not a GCP expert, so I'm not familiar with it also, but yeah, you can write a detection rule like this, and yep. So in conclusion about selecting right detection engine, let me conclude it briefly. Yara is very good at binary, but it's not good at structured data. Sigma is good at flat structured data and also consecutive data sets like a list of logs, but it's not good at, it's bad at non-flat structured data and also binary. Lego is good at any kind of structured data, but bad at consecutive data sets like list of logs and also bad at binary. And there is an appendix about Lego's performance, and let me skip it, but in short, it's not so fast, but it's not so slow, yeah. Another appendix or discussion point is why not using a generic programming language like Java or Python for detection engineering, which is a very interesting topic and it's a controversial topic. But it's a interesting point, but let me skip it because of the time limitation. I already shared this note in the HackMD, so please read it if you are interested in it. Please read it later if you are interested in it. Yeah. Next section, next chips are about test. What I want to say is very simple. Please write tests, and tests. You have to write unit tests for covering edge cases, and it's easy to synthesize data for testing by using property-based testing libraries such as Hypothesis. It's like a fudging for testing, and you can make a solid test by using this library. I recommend to use it, and also please write integration or end-to-end test for assuring the integration of third-party or internal modules and functions. And also, I recommend to write tests for detecting schema drift. I will explain it later. And let me share some techniques to do unit tests for Lego, Sigma, and Yara. First one is about Lego. Lego provides test functionality by default, and you can write a test rule like this, and it says it does something like it's the input data, input one, my input. If this data given, allow should be true. And if input 2 is given, allow should be false. You can write a test like this, and you can execute this test by using the test command OPA test. And Yara, VirusTotal Yara X provides clean API for testing. First, you should compile a Yara rule like this. Then you can scan the input, and you can get a result. Then you can assert the result, what should be. For example, more practically, I think this is a good example. From Cape, it gives this file and assert the matches. Name should be Bumblebee. It should have those strings and it should have those addresses. So you can write a unit test like this for Yara rule. And Sigma is a bit tricky because technically speaking, Sigma is a format. Sigma is not a detection engine. But you can test a Sigma rule with Asma, which is a tool I forked from Cyber Center Canada's PySigma. And like a Yellow X, you can compile a Sigma rule into the rule object, and you can assert whether it matches with the following input or not, like this. Alternatively, you can consider using a Sigma test. I haven't used it, so I'm not sure. I'm not familiar with it, but it's a Go-based Sigma test tool, and you can run tests by using it. So before I said using the property-based testing is good for, it's like a fudging and it's good for unit test. But again, let me skip it, and please read it if you are interested in it. Integration test. In our cases, my subject is phishing website detection, so doing integration test is easy. I set up a fake phishing web server, phishing website server by using PyTest HTTP server, which allows us to create a HTTP server on the fly, and we can do integration tests so easily. But I think detection engineering is mostly common for the shim and the endpoint detection. So it's writing integration test for shim and the endpoints are a bit difficult, but there are some tools and example for that. So, for example, Splunk, the attack range, Red Canary's Atomic Red Team, and MITRE's Caldera. They are tools to assist do integration test in adversary enumeration. Also, I think Threat Panther's detection as code example. This is a good example for doing integration test against shim. For example, this is a GitHub action workflow for doing the integration test for shim, sumo logic. It does deploy to dev job. It does create an infrastructure by using Terraform. After that, it triggers detection, which means create a dummy event logs by using Python script. Then finally, it checks for alerts, which means the whether shim triggers specific alerts or not by using the, again, Python script. So you can write a integration test for shim like that. I said that it's good to write a test for schema drift. So let me explain it briefly. Schema drift is a case where your sources often changes metadata, field columns, and types can be added, removed, or changed on the fly. It means, for example, you have a field A before, but after some developments, field A has been deprecated, removed. But if you have a detection rule which relies on field A, it can be very problematic. So it's good to detect whether there is no schema drift or not. And again, I don't have much time to explain it, but you can do that by defining data model in programmatic way. For example, we use Pydantic, which is a very famous Python data serialization model, schema definition library, and we define the data as Pydantic model, and we have fixtures test data, and we do the matches fixture data test data by using the Pydantic data model. Then if there is a diff, it means it has a schema drift. So maybe my explanation is very bad, and you may think, what are you saying about it? There is a test code. So you please read it later if you cannot understand what is concept of this technique. And how to do tests. There is a discussion about how to do tests, and this is a blog post, a 5-year retrospective on detection as code, which is a blog post which is written by the original author of Detection What's Code, and he says that it's good to adopt TDD approach, test-driven development approach in detection engineering. And I somewhat agree with this opinion, but TDD is extreme way of thinking, and to be honest, TDD is very boring, and I don't like that. So I would say it's good to use test data-driven development with instead of TDD, test-driven development. Test data-driven development means you don't need to write a test, but you need to define a test of data. Then test data converts into the test case. You can do that by setting some conventions, but again, we don't have much time, so let me skip it, and please read it later if you are interested in it. Next section, next chips are about Rint. I recommend to always use a Rinter and tame a Rinter to make it fit with your hands. And there are, let me share some Rinters for Lego and Sigma and Yara. Lego has a definitive Rinter, which is known as Legal. And you can detect a common gotcha like this Lego rule has same things, same comparison twice, input foo equal bar twice. Then if you run a legal against this rule, it detects that this issue by duplicate rule. Then you can, how to say, streamline a detection rule better. There are also several Rint tools for Sigma, and I recommend to use Sigma CLI, which is the official Sigma command line tool, and it has Sigma check command. And if you run Sigma check command against above Sigma rule, it says it outputs 5 errors. For example, rule has no identifier, rule has no date, rule file name is too short or long, and this one is very important. Dangling detection issue, which means rule defines detection that is not referenced in the condition. It means that in the detection, there is a selection and who, but who is not referenced in condition. So there is something wrong. Who should be removed or who should be defined in the condition. So you can detect the common gotcha like this by using this tool. Also, Yara has some Rinters. For example, Cyber Center Canada's CCCS Yara and Yara rule, Yara HQ's Yara Hodge. And let me share how to use CCCS Yara. CCCS Yara provides a Yara validator, which is a Rinter for Yara rule. And if you run Yara rule, Yara validator against this Yara rule, it outputs the errors. For example, ID is missing, but fingerprint is missing, blah, blah, blah. But sometimes you may feel like we don't need ID. So this is the reason I say it's good to tame a Rinter to make it fit with your hands. So there are maybe Rinter makes you, how to say, irritate, and with a reasonable reasoning. So in such case, you have a choice to configure the Rinter. For example, disable the ID error. Oh, excuse me. It's okay to not have a data, something like that. So make it fit with your hand. It's important. Optionally and additionally, I also recommend to use a Git hook manager, such as Evil Martian's left hook, and run Rint on pre-commit or pre-push. For example, if you make a Git commit, it automatically runs a Rinter, and you can get the alert before you push. For example, you can integrate with Lego with the foreign command, and Sigma also can be integrated like this. Yara is also same, and Next section is about deployment. Tips about deployment is very simple. Please automate it. I have nothing to add more. And also response. It's good to automate the response task as much as possible also. For example, I think for example, Wally already explained how we do response, but most of them are automated by, for example, we said we report a URL to block list, Google Safe Browsing, and Google Safe Browsing has a hidden undocumented API for reporting, and we utilize it for the automated report. And also, we do a report for registrar and the hosting provider, and there is a tool to find where to abuse instead of doing who is and checking the who is result manually. There, for example, abuse finder of who's and abuse who is. You can use those tools for automate the finder where to report. And we use abuse who is, which is a Sigma-based tool, and yeah, you can detect where to report like this. Yeah. And I have some other tips against the successful detection as code adaptation. And the first one is having a good feedback loop. In other words, have a way to know false negatives and the positives. We use getSentry for error issue tracking, and we get an issue if an input from trusted sources. For example, report from customer support is classified as not fishy. We get the alert, and then we can create a new rule or improve existing rule. Also, next tips is about documentation. I recommend to do documentation through the metadata, because I think a detection rule should have a corresponding document for what is it, how it works, something like that. And about managing documentation outside of VCS Git repository can be tricky. For example, managing docs in Confluence, because such docs are easy to be outdated. So I recommend to document a rule through metadata. It ensures the single source of truth principle. For example, Lego can have metadata block. Lego can have metadata block to make it self-explanatory. For example, you can define a title, description, author, blah 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 to make it it's understandable what is it, how it works. And also, YARC also can have meta block, but there is no official recommendation for what should be documented in the metadata. So I recommend to follow CCCS YARA spec, which is this is a spec for CCCS YARA, and it defines the list of metadata which should be defined. For example, ID, fingerprint, blah blah blah, and I think this is a good example. Wait a moment. Yeah, it has this kind of metadata. For example, status, sharing, description, and MITRE attack ID and hash of sample. This makes you to understand what is it. So I think it's very good. And also, Sigma also has the metadata field to describe what is it. And the official Sigma repository has a good Sigma rule, and you can make it by writing those metadata. The detection rule is easy to understand. For example, description, references, and tags, the MITRE attack IDs. So if you read this detection rule, you can understand what is it easily. So I recommend to do documentation through the metadata. So finally, wrap up and the key takeaways. In short, detection as code is a practice that applies DevOps best practice into detection engineering. And I believe data modeling is the king, rules all, and so you should create a good data modeling before doing the detection engineering. And also, I recommend to write tests to get self or achieve confidence. And you may feel that writing test is boring, but a TDD approach makes it easy. And I also recommend to make things verbose and explicit. As code approach increases transparency in general. Adding metadata in detection rule makes them even better. And I recommend to add here to the single source of truth principle. And last but not least, automate all the things. And finally, as an acknowledgement, I'd like to say thanks to Thanatos-san and Sepi-san for reviewing this paper, and also say thanks to you guys for listening, and thanks for the interpreter. Yeah.
好，非常谢谢两位讲师带来精彩演讲。那所以把这些所有侦测的规则，刚介绍非常多不同的语法跟引擎，如果都写成像程式码一样，有 test 有完整的测试流程，就可以达到测试稳定。So we have time for maybe Q&A and anyone has questions. Okay, yeah, can you use a microphone near the table?
Thank you very much for this comprehensive and interesting talk. And I'm wondering, like, for your talk, I guess you're focusing on phishing websites you detect, right? And I'm wondering, like, I've seen a lot of like YouTube ads trying to abuse your platform to use, for example, create a group to like siphon people into it and try to do some like butchering scam or something like that. And I feel like there are a like well-structured attack using like a well-structured attack format and website format abusing this kind of behavior. And I'm wondering like if it's possible to use these like tools like Rego or even like basic Sigma or Yara rules to detect this kind of abuse on your platform.
So your question about how to detect scams on YouTube, right? No.
I'm wondering like for these websites, they use embed QR codes of line groups on them. And I guess that user's browser would try to access these embeds, and they would have like referrer header entries. And I'm wondering like if it's possible to use these referrers to access these scam links or scam websites and try to detect these kind of scams. Thank you.
It's a good question, but I think we don't have many things to answer. Do you have any comment?
No, I mean currently we just
whether it is a legitimate QR code or not is very difficult. For example, if it is a phishing website, it's clear that it tries to steal credentials, but QR code link to the, for example, open chat group or any kind of line group, which is very difficult to distinguish whether it's scam or legit, I think. So there is no silver bullet at the moment, I guess.
Okay, so we don't have a lot of time, so let's applause and thank you for the great talk again. And if you have a question, please come to the stage.